Welcome to the introduction of sequential logic in digital logic and design. In this module, we will explore the fundamentals of sequential circuits. Sequential logic circuits are a type of logic circuit where the outputs depend not only on the current inputs but also on the past history, or previous states of the circuit. This is different from combinational logic, where the output is solely determined by the current inputs. A key characteristic of sequential logic is that the output is a function of both the current inputs and the past history. Here's a comparison between combinational and sequential logic. In combinational logic, the output depends only on the current inputs. However, in sequential logic, the output depends on the current inputs and also on the previous states of the circuit. Let's delve into the characteristics of combinational circuits. Combinational circuits do not have memory elements. They provide an instant response to input changes, meaning the output changes almost immediately when the input changes. Also, for the same input, a combinational circuit will always produce the same output. Examples of combinational circuits include gates, OR gates, NOT gates, adders, and multiplexers. Now, let's discuss the characteristics of sequential circuits. Unlike combinational circuits, sequential circuits contain memory elements that store information about past states. The output of a sequential circuit often depends on a clock signal, which synchronizes the changes in the circuit. Sequential circuits store previous state information, allowing them to remember past inputs and states. Examples of sequential circuits include flip-flops, latches, counters, and registers. Memory elements are storage devices that can hold binary information, zeros and ones, between clock pulses. These elements enable circuits to remember previous states, making sequential logic possible. Without memory elements, circuits would only respond to current inputs like combinational logic. A clock signal synchronizes state changes in sequential circuits. It controls when memory elements update their stored values. Overall, it provides a timing reference for all operations within the sequential circuit, ensuring that everything happens in a coordinated manner. Here's a summary of the key differences between combinational and sequential circuits. Combinational circuits do not have memory elements, while sequential circuits do. In combinational circuits, the output is a function of the inputs only. In sequential circuits, the output is a function of both the inputs and the current state of the circuit. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.